Welcome back, viewers, to the program The Stellar Twin Voyagers. Today, I, Nova A239, will once again guide you through the journey of siblings striving to fulfill their colorful dreams. Let's together explore the eternity of a million lifetimes amidst the ocean of stars. Prepare to be mesmerized by the wonders of the universe and stories full of hope that will inspire us all. The sun has risen again on the eastern horizon, signaling the beginning of another adventure for our young shepherds, Aster and Cosmo. Cosmo, wake up. Cosmo, come on, wake up, said Aster, gently shaking his younger brother who was still sound asleep. Yeah, bro, yeah, I'm awake, muttered Cosmo slowly, rubbing his eyes. Come on, don't forget we have to go with Grandpa to the village hall for the meeting. It's quite far from our home. Let's go quickly, bring the sheep to graze and fetch some water first, said Aster. Aster and Cosmo started tidying up their beds and soon left the room to meet their parents and Grandpa. Good morning, Dad, Mom, Grandpa, greeted Aster and Cosmo. Oh, you're up already, said Grandpa, good morning. We're going to fetch water first, Grandpa, said Aster, then took Cosmo along, carrying their buckets. They quickly ran down the hill towards the well to fetch water, then returned with 2 large buckets full of water. We're back, Mom, we'll leave the buckets here. We're going to take the sheep out to graze first, said Aster. They hurried to the sheep pen, where Cosmo opened the gate while Aster herded the sheep out into the grazing area. After letting their flock graze and drink water in the nearby grasslands, Aster and Cosmo led their sheep back to the pen and locked the gate. We're done, let's head back home, said Aster. Cosmo nodded, and they quickly walked back home. We're back, Dad, Grandpa, Mom, announced Cosmo upon entering the house. Ah, welcome back my sons. Quickly clean yourselves up in the backyard, then join us for breakfast, said Mom. All right, Mom, said Aster, then hurried Cosmo to their room to get changed and grab towels. They ran to the backyard to wash up and then rejoined Grandpa and their parents. Let's have breakfast, said Mom as she served breakfast one by one. Enjoy your meal, everyone said happily as they began eating. Before they knew it, breakfast was finished. Dad and Grandpa got ready in the front yard, while Aster and Cosmo helped their mom clean up the dishes. Once they were done, they ran to meet Dad and Grandpa. Hold on, said Dad, wait here. He ran inside and soon came back out with 4 warm jackets. The weather is getting colder, we should bring these in case it gets too cold later this afternoon. Now, let's get going. Today we're cycling. Cosmo, will you ride with Dad or Grandpa? Said Dad. Awesome, riding bikes. I'll go with Grandpa, Dad, said Cosmo. All right then, Aster, you ride with Dad, said Dad. Dad and Grandpa started pedaling their bikes towards the village hall. While pedaling, they sang to ward off boredom, enjoying the fresh morning air and warmth of the sun's rays. Before they knew it, they had finally arrived at the village hall. There, many villagers had already gathered. Seeing Grandpa's arrival, the villagers greeted him. Good morning, elder of the village. How are you? Grandpa smiled and greeted each villager in return. Slowly, the village hall began to fill up with villagers. Let's find some seats, said Dad. The 4 of them sat down and waited for the other attendees to arrive for the agricultural extension program. By now, the clock on the wall showed 9 o'clock, and it was time for the event to begin. Grandpa walked up to the podium and gave his opening remarks. Accompanied by Dad and several other farmers, Grandpa began explaining each aspect of the farming extension program, introducing various improved seed varieties that had been developed. Aster and Cosmo, who didn't fully understand the discussions, spent their time whispering and exchanging opinions while reading the book their grandpa had given them. Before they knew it, almost 3 hours had passed. Grandpa announced, all right, villagers, it's midday now. Let's take a short break. Please have your lunches. We will resume after lunch. Grandpa and Dad approached Aster and Cosmo. What are you 2 up to? Asked Dad. Reading the book Grandpa gave us, Dad, said Aster. Ha ha ha, finding the event a bit boring, are we? Chuckled Grandpa. Aster scratched his head and smiled sheepishly. Well, we didn't quite understand the talks, Grandpa. But you and Dad are amazing, being able to host and speak in front of so many people. It's our duty, said Dad, patting his sons' heads. All right, wait here. Grandpa and I will grab our lunch. Okay, Dad, said Aster and Cosmo. Shortly after, Dad and Grandpa returned and sat with them. Here, take your food. Let's have lunch, said Dad, handing over 2 lunch boxes to his sons. Thank you, Dad, said the 2 boys. They enjoyed their meal and took a rest. Grandpa closed his eyes briefly, then checked the wall clock. It's almost time. All right, today Grandpa will tell you a few things. Maybe your dad will help later too. Interested? Yes, Grandpa, yes, exclaimed both grandchildren eagerly. All right, perhaps today Grandpa will talk about nebulae, supernovae, novae, and Messier objects. Have you heard of Messier objects before? Asked Grandpa. We just read about them in this book, Grandpa, said Cosmo. Ah, good. Grandpa will start with Messier objects then. So, Messier objects are a set of non-stellar celestial objects catalogued by the French astronomer Charles Messier in the 18th century. The Messier catalog contains 110 objects, including galaxies, star clusters, nebulae, and remnants of supernovae. The main purpose of its creation was to assist astronomers in identifying objects often mistaken for comets. There are several Messier objects that are quite famous. For example, Messier 1M1 is the Crab Nebula, located in the constellation Taurus. The remnant of this supernova occurred in the 11th century. It is one of the most famous objects in the Messier catalog. Then there is Messier 31M31, known as the Andromeda Galaxy. It is the largest spiral galaxy located near the Milky Way and the nearest neighboring galaxy to Earth. It can be seen with the naked eye as a blurry spot in the night sky. Next is Messier 42M42, the Orion Nebula, a bright nebula located in the Orion Belt, where new stars are born. It is one of the most famous and easily observable objects in the sky. Additionally, there is Messier 45M45, or the Pleiades cluster, often discussed. It is an open star cluster located in the Taurus constellation. It is also known as the 7 Sisters, or Pleiades. This cluster is one of the closest to Earth and easily observable with the naked eye. Then there is Messier 51M51, or the Whirlpool Galaxy. It is a spiral galaxy interacting with its companion galaxy located in Canes Venatici. This is one of the fascinating galaxy interactions in the Messier catalog. However, the Messier catalog is not the only one. There is also, for example, the New General Catalog (NGC) created by John Louis Emile Dreyer in 1888, which contains over 7,800 celestial objects including galaxies, nebulae, and star clusters. Each object in this catalog is assigned an NGC number, for example, NGC 224 Andromeda Galaxy and NGC 1976 Orion Nebula. There is also the Index Catalog (IC) created by John Louis Emile Dreyer, initially in 1895 ICI and 1908 IC2. This is an extension of the NGC catalog, with both parts together adding more than 5,000 additional objects. For instance, IC 342 Giraffe Galaxy and IC 1805 Heart Nebula. Then there is the Catalog of Principal Galaxies (PGC) created by George de Vaucouleurs and his team, established in 1989. This catalog includes over 73,000 galaxies. Object names are based on PGC numbers, for example, PGC 2557, NGC 224, Andromeda Galaxy. The Uppsala General Catalog, UGC, by Peter Nilsson in 1973 contains approximately 12,921 galaxies in the northern sky. For example, UGC 2885, Large Galaxy in Perseus. The Harvard Revised Photometry Catalog, hour created by the Harvard College Observatory, includes about 9,110 bright stars in the sky. For example, HR 7001 Vega. Then there is the Henry Draper Catalog, HD, by Edward Charles Pickering, 1918-1924, containing spectra and data on over 225,000 stars. For example, HD 189,733, star with an extrasolar planet. The Bright Star Catalog, BSC, by Yale University includes over 9,000 bright stars. For example, HR 7001 Vega and HR 2491 Sirius. The Gliese Catalog of Nearby Stars, GL, by Wilhelm Gliese focuses on stars within 25 parsecs of the Sun. For example, Gliese 581, star famous for several extrasolar planets. Then there is the Smithsonian Astrophysical Observatory Star Catalog, SAO, by the Smithsonian Astrophysical Observatory, which contains about 258,997 stars. For example, SAO 206,462, star with a protoplanetary disk. There is also the 2-Micron All-Sky Survey, 2MASS, by the University of Massachusetts and the Infrared Processing and Analysis Center, IPAC. This survey includes infrared data from over 300 million objects, for example, 2MASS J09393548248279 brown dwarf star. The General Catalog of Variable Stars, GCVS, by B. V. Kukarkan, P. Paranago, et al., contains information on more than 46,000 variable stars. For example, Betelgeuse Alpha Orionis listed as a variable in the GCVS. The Asteroid Designation System by the International Astronomical Union, IAU, where asteroids are initially given numeric names after confirming their orbits, followed by more descriptive names or names of people. For example, 1 series, 433 Eros. Then there is the Comet Designation System by the International Astronomical Union, IAU, where comets are named based on the year of their discovery, followed by a letter indicating the order of discovery and a chronological number. For example, Halley's Comet 1P Halley and Comet NEOWISE C 2020 F3. The Exoplanet Designation System by the International Astronomical Union, IAU, for naming exoplanets consists of the name of their parent star followed by a lowercase letter indicating the order of discovery. For example, 51 Pegasi B and Kepler 186F. The International Celestial Reference Frame, ICRF, by the International Astronomical Union, IAU, is a reference frame containing high-precision positions of over 600 radio objects, for example, Quasar 3C273. Each naming system has different goals and focuses, whether for stars, galaxies, nebulae, planets, asteroids, or comets, providing astronomers with structured and standardized ways to identify and classify objects in the universe. Yes, it's quite exhaustive indeed. Perhaps Grandpa will take a short rest now. Your father might continue explaining for you. Of course, said Dad. Now, Dad will explain to you about nebulae. Nebulae are large interstellar clouds of gas and dust that serve as birthplaces for stars and planetary systems. They consist of gases such as hydrogen and helium, as well as dust and other particles. Nebulae come in various shapes, sizes, and properties. There are several types of nebulae. First, there are emission nebulae. These nebulae consist of very hot gases that illuminate themselves. The light received is from the emission of gases, such as hydrogen alpha. Examples include the Orion Nebula M42 and the Lobster Nebula M17. Next, there are reflection nebulae. These nebulae consist of dust and gases that scatter light from surrounding stars. The light received is the result of the reflection of starlight passing through the nebula dust. Examples include the Trifid Nebula M20 and the Pleiades Nebula M45. Thirdly, there are planetary nebulae. These form when sun-like stars shed their outer layers at the end of their lives. Examples include the Helix Nebula NGC 7293 and the Dumbbell Nebula M27. Then there are dark nebulae, also known as absorption nebulae, formed by dust and gases that filter light from stars behind them. Examples include the Horsehead Nebula B33 and the Rho-Ophiuchi Nebula. Next, Grandpa will explain about supernovae and novae. Supernovae and novae are two types of stellar explosions that mark the final stages of stellar evolution. Both phenomena are highly spectacular and provide important insights into the processes occurring in the universe. A supernova is an extremely powerful stellar explosion that occurs when a star reaches the end of its life. There are two main types of supernovae. Firstly, type Ia supernovae occur in binary star systems where one star is a white dwarf. If the white dwarf accretes matter from its companion star until it reaches a critical mass, the Chandrasekhar limit, around 1.4 times the mass of the Sun, it undergoes a thermonuclear explosion. Its spectrum does not show hydrogen but exhibits strong silicon lines. An example is SN 1572 Tycho supernova, discovered by Tycho Brahe in the constellation Cassiopeia. The second type is type II supernovae. These occur when a massive star, more than 8 times the mass of the Sun, runs out of nuclear fuel and its core collapses. This triggers a massive explosion that ejects the star's outer layers. Its spectrum shows strong hydrogen lines. An example is SN 1987A, discovered in the Large Magellanic Cloud, which is the closest supernova visible from Earth since the invention of the telescope. In addition to types Ia and II, there are several subtypes of supernovae based on their spectral characteristics. Firstly, there are type IB and IC supernovae. These occur in massive stars that have lost most or all of their hydrogen layers before exploding. Type IB shows helium lines, while type IC does not show hydrogen or helium in its spectrum. An example is supernova 1994I in the galaxy M51 Whirlpool Galaxy. In addition to supernovae, we also know about novae. Novae are explosions that occur on the surface of a white dwarf in a binary star system. When a white dwarf accretes matter from its companion star, this material accumulates on the white dwarf's surface until the pressure and temperature are high enough to trigger explosive nuclear fusion reactions. An example is Nova Cygni 1975, discovered in the constellation Cygnus. There are several types of novae based on their mechanisms and the rate at which they brighten. Firstly, there are classical novae, which occur when a white dwarf accretes matter from its companion star. This material accumulates on the white dwarf's surface until the pressure and temperature are high enough to trigger explosive nuclear fusion. This explosion dramatically increases the star's brightness, usually by a factor of thousands. An An example is nova Cygni 1975. Then there are recurrent novae, which are similar to classical novae but the explosion occurs repeatedly at regular intervals. The outbursts happen more frequently, typically within decades. An example is T. Pyxidus, which has experienced several eruptions since the 19th century. Lastly, there are dwarf novae, which occur in binary systems with a white dwarf and a companion star. Material accreted by the white dwarf triggers a thermonuclear explosion. These explosions are usually less dramatic compared to classical novae. An example is V1500 Cygni. There are several differences between supernovae and novae. Firstly, in terms of explosion energy, supernovae are much more energetic and brighter compared to novae. Secondly, regarding duration, the light from supernovae can last for several months to years, while nova light typically lasts only a few weeks to months. Thirdly, concerning the process, supernovae usually involve the destruction of the star's entire or majority of its mass, while novae only involve the surface layers of the star and do not destroy the white dwarf. There are some very interesting supernovae and novae. Firstly, supernova 1054 Crab Nebula, which occurred in 1054 and was observed by Chinese and Arab astronomers. The remnants of this explosion are now known as the Crab Nebula, located in the constellation Taurus. Then there is supernova 1604 Kepler supernova, which occurred in the constellation Ophiuchus and was named after Johannes Kepler, who documented it. There is also supernova 1006, which occurred in the constellation Lupus and is the brightest supernova recorded in history. Lastly, there is nova Persei 1901, also known as GK Persei, which was a bright nova seen in the constellation Perseus. Supernovae and novae are extremely important in astronomy for several reasons. Firstly, type Ia supernovae are often used as standard candles to measure distances between galaxies, helping to determine the rate of expansion of the universe. Secondly, type 2 supernovae provide information about the final stages of massive star lives and the spread of heavy elements in the universe. Novae also help scientists understand binary star interactions and white dwarf evolution. How fascinating, isn't it? Yes, it's very interesting, Dad, said Asto and Cosmo. Well, it's been quite a journey of learning about various fascinating facts about the universe. It seems like your dad is also tired now. Let's take rest now. Grandpa and Dad will tell you more the other day, said Grandpa. Thanks a lot, having told us many great stories, Dad, Grandpa. We will read our book now, said Aster and Cosmo. You're welcome, said Grandpa and Dad. Thus concludes today's episode of the Stellar Twin Voyagers. Wasn't it enjoyable? Would you like to hear more amazing tales from our shepherd boys' adventures as they write their stories among the millions of pearls in the night sky? Therefore, stay with us on this program, and we'll meet again in the next episode. In short, I'm Nova A239, delighted to share stories with you today. Until next time, let's continue to pursue our dreams.